Okay, so this is part 2, so this is a different type of proof. This is proof by exhaustion. Now with these sorts of ones, you've generally got to split them into smaller parts and then prove them individually, which means then overall that it'll be true. There is a thing called disproving things as well, so to do that we will give a counter example that proves that it isn't true for everything, okay? So that's what we're going to be doing for 2 and 3, okay? But we'll get later on. Now these ones are quite similar, especially the first one, to what we were used to back in GCSE. So to begin with EG1, we need to prove that all square numbers are either a multiple of 4 or one more than a multiple of 4. So this is where I said in the other video, remember that you have to remember things like an odd number, not even on the line there, odd number is always 2n plus 1, and an even number is always 2n, okay? So n can be any number, we obviously don't know what it is, which is why we've written n. That multiplied with 2 would always be even, okay? Now if that's even, one more added onto it would always be an odd one because of how numbers work, how it goes from odd to even. So we're splitting up this problem into 2, one for odd numbers and one for even numbers. So we'll do them individually and prove that both of them work, okay? So I'm going to start with the odd numbers, okay? So for odd numbers, if we square an odd number, so 2n plus 1 squared, okay, we expand it, so remember when you're expanding that is the same as that bracket multiplied by itself. Now I know some people can do it in your head, brilliant if you can. If you end up just writing 4n squared plus 1, make sure you do that and then you won't make that mistake again. So 2n times 2n gives us 4n squared. 1 times 1 gives you 1. 1 times 2n is 2n. And 1 times another 2n is 2n. And that simplifies to 4n squared plus 4n plus 1. Now the first two terms have a 4 in common, so I'm just going to factorise a 4 out for those two. N plus 1. So this is telling me that whatever n is, doesn't matter what it is, it's a multiple of 4 because we've got the 4 at the front, and then it's one more because we've added 1 after, okay? So our odd one is this part here. It's a multiple of 4 plus 1. Okay, so that's for the odds. We're then going to do the same for the evens. So an even is 2n squared. Okay, so that's going to be 4n squared, which is just going to be a multiple of 4. So multiple of 4. Okay, you've then got to write a little bit of a statement just saying that they both work. So they always give you a multiple of 4 or a multiple of 4 plus 1. Okay, obviously if you're very good at English you can write a bit better than me, but that's what you need to write. Okay, now the next one is sort of just practicing your disproving, okay? So we need to prove that it's not true that the sum of two consecutive prime numbers is always even. So consecutive means next to, so it means two numbers that are next to each other, okay? It's prime, so you've got to remember also your prime numbers, okay? So prime numbers 2, 3, 5, 7, 11 and so on. Okay, we need to pick 2, so generally pick the smallest ones just because it makes it easier and see if that's not true. If that one doesn't work, just keep trying another one. Okay, so we're going to start with 2 plus 3, so also remembering that sum just means that you're adding them, okay? So the sum of two consecutive prime numbers, so 2 add 3 gives us 5. is always even. Okay, so this, obviously 5 is odd. So then we'd say, using a counter example, this statement is not true. Okay, and that's all you need to do. Now, if that one didn't work, as I said, you just keep going. But I think actually that is the only one that does work. The rest of them will always be even. It's because of the 2. Okay. Now, EG3, I think, is the hardest one you could get, in my opinion. Okay, because it's sort of a bit backwards. So we need to prove that this works. But the issue is we obviously can't start with it to prove it. So they call it jotting in the book. To be honest, it just means you've got to do a bit of work before you can actually prove it. So I'm going to do this in a little bubble on this side in red of what they expect you to do. Okay, so what I'm going to do is I'm going to simplify this a little bit. I don't like the fractions or anything like that, so I'm going to manage those. And then we're going to end up with an inequality that looks a bit nicer. Once we've done that, we're then going to use that to prove that this works, okay? That's what I mean by it's a little bit backwards. And it is just one of those things that you will need to practice when you have a bit more time, obviously, to go over it. So, we start off with, is it x first? Yeah. X over y plus y over x is bigger or equal. Oh, I don't know why I wrote 0. 2. Okay, so they called this jotting. Okay, it's just workings before you can actually start. Okay, so to get rid of the fractions, I'm going to have them both have the same denominator. So I'm going to multiply this one both by x on the top and the bottom, and this one by y on the top and the bottom. So we got x squared over xy plus y squared over xy, and that's still bigger or equal to 2. Now, because they've got the same denominator, we can then write it as 1 what would I say? 1 fraction, there you go. Okay. Now I'm going to multiply by the denominator. So to get rid of the fraction, so we've got x squared plus y squared is bigger than or equal to 2xy. Okay, now it can actually simplify further, so I'm going to subtract 2xy from both sides. So we've got x squared minus 2xy plus y squared is bigger or equal to 0. Now, some people would just recognise this very quickly. If you don't, this actually does factorise, and it factorises to this, x minus y squared. Okay, or you could write it as 2 brackets if you wanted. Now, this is what we start our proof with. Okay, so I'm going to do this. Start proof. Okay, that's why it's confusing. So we've done all that work when actually we haven't even started proving it yet. Okay, oh, can you see right at the bottom? Just about. I haven't got a big enough table. There we go. Okay, so we're actually starting the proof now. So we're going to begin with this part here. Okay, so we're just considering the x minus y squared. Okay, and that's bigger or equal to 0. So normally when we have brackets, we then expand them. So we've got x squared minus 2xy plus y squared is bigger or equal to 0. Now, we are told that x and y are both positive. Okay, so I'm going to divide everything by xy. Okay. So we're going to end up having, I'm not going to simplify it just yet, I'm just going to write it out first. xy bigger equal to 0. Now 0 divided by xy would still be 0, so that's okay. Okay, now this we're allowed to do because it says that they're both positive, but we do need to write a little thing saying that x and y are bigger than 0, okay? So once we've done that, we can then simplify it. So this part, one of the x's will cancel, so we'll still have one x at the top, but then we'll still have the y being divided, so that's going to be there. X, y's appear in both the second term, so that's just going to be -2. And for this one, similar to that, one of the y's would cancel, but the x won't. Okay, so that's nearly what we wanted to show, but actually we can add 2 to both sides just to make it proper. Okay, so you've just got to remember, you've got to do a bit of workings before you can actually start proving it. Okay, so that's part A done. Part B, so we need to come up with a counterexample of when it doesn't work when they're not both positive. Okay, now you can pick any 2 numbers you want. I'm going to pick x is -3 and y is 6, okay, just because I can divide those fairly nicely in my head. So if I put those into here, okay, I'm going to ignore the bigger than 2 at the moment. I'm just going to sub them into the left hand side. So we've got -3 divided by 6 plus 6 divided by -3. Now this is going to give me -0.5. This is going to be -2, so that simplifies to -2.5. Okay, now that obviously isn't right because this is not bigger or equal to 2. Okay, so therefore, oh, not written therefore, when x is -3 and y is 6, this formula is not true. Okay, so just a little statement afterwards.